In this lecture, we will go through different document similarity measures like precision recall and F measure, dice coefficient, Jaccard coefficient, cosine similarity, asymmetric similarity, Euclidean distance, and Manhattan block distance. These are the general matching based similarity. This is also matching based similarity but of different nature, and these are the distance based similarity measures. Actually, similarity measure is a function which computes the degree of similarity between pair of text objects. Similarity measures are very important for text mining. We can summarize the major use of similarity measure as there are two major use. First, maybe the similarity between two documents or document versus query terms, and second is the document ranking. The similarity measure can be used to calculate the similarity between two documents, two queries, or document and one query. We can use the similarity measure to categorize the documents. Generally, some similarity measures are used in clustering. Some similarity measures are used in organizing the documents. Document ranking. Similarity measure score can be used to rank the documents with respect to any query term, basically used with cosine similarity measures and Jaccard and dice coefficients also. Some important points: presence of large number of similarity measures. Actually, as I discussed earlier, there exists a lot of similarity measure or similarity measures based technique, but none of them are the best. According to the situation, we can select any of them for optimal performance. Selection of similarity measures. Generally, selection of similarity measures based upon choice or requirement, so that we can get optimal performance. So let us first start with similarity measures based on matching. The basic part is precision, recall, and F measure. Suppose in a document space, this is retrieved and this is relevant. For example, we will go through this example. Suppose a sample space S, which contains the documents, a set of all alphabets. Contains set of all alphabets A to Z. Now, a system extracts these words or these alphabets from this collection, of which we consider that these are the relevant or that we actually wanted, and these are the set of alphabets that we get through some system. Then precision will be the returned relevant documents divided by total number of retrieved documents. Here we retrieved total 5 letters, of which now we will check which all 5 are common. So we will find that this 3 is matching and Y and W doesn't exist in these 3. So here A intersection B will be 3 and this will be 5. Here also divided by B, which is 10. So this is the recall. Total relevant documents means recall is equal to return relevant documents divided by total relevant documents. This is the set of terms which are common in retrieved and relevant documents. This is very simple measure and generally used in some measures like accuracy of key phrase, accuracy of clusters, how many clusters generally we wanted, how many clusters we machine generated, and what are their accuracy of the system vision which clusters the document. We can use the precision recall and F measure as a simple measure and primary measure. Now F measure is the harmonic mean of precision and recall. So it is equal to 2p into r divided by p plus r. Now the another coefficient is the dice coefficient. Dice coefficient is actually the harmonic mean of precision and recall. So dice coefficient is equal to 1 by p plus 1 by r. Now for this set of relevant and retrieved, it can be calculated like this: 2 into relevant, 2 into set of documents which are relevant and retrieved both divided by cardinality of relevant documents plus cardinality of retrieved documents. Actually, harmonic mean of n numbers like x1 to xn can be calculated as n divided by 1 by x1 plus 1 by x2 plus till 1 by xn is equal to n divided by I is equal to 1 to n 1 divided by xi. Now some important points. The value of dice coefficient ranges from 0 to 1. The corresponding difference function is not a proper distance metric and doesn't possess the property of triangular inequality. This is general demerits of dice coefficient, that it doesn't satisfy the concept, doesn't satisfy the triangular inequality like this. The simplest counterexample, triangular inequality means sum of two sides will be always greater than third side and so on. It doesn't satisfy this property. A counterexample like, suppose we have three sets A, B and AB. The distance between the first two is being 1 and the difference between the third and each of the others is being 1/3. Now using some constant to explain the concept of dice coefficient, the similarity with respect to query term Q and document DJ can be calculated as we consider query term Q as A and document D as B. Query term Q is the retrieve and query term D is a relievant. So now the coefficients, dice coefficients will be mod of A intersection B divided by alpha into A plus 1 minus alpha into B, and it can be given as from k is equal to 1 to n, where n is the total number of documents in the collection, the query word Q exists in the document J divided by alpha into presence of query word Q in document ID K whole square plus 1 minus alpha into k is equal to 1 to n, total number of documents, into presence of query term J in document K. So here similarity between those documents can be calculated as sum of presence of query term Q and J, presence of query term Q and J, product of presence of query term Q and J in document K divided by alpha into summation of presence of query term Q in document K whole square of this part, and same here. If alpha is greater than 0.5, then it gives some importance to precision. If alpha is greater than 0.5, then this part will be more important. If alpha is less than 0.5, then recall will be more important in calculation. If you use alpha is equal to 0.5, then it will be a simple harmonic mean like this. Now this is a simple exercise. Calculate the bigram based similarity between two strings. First is night and second is NACST by using dice coefficients. So it is very simple. For example, can be written as NI, IG, GH and ST. Now second NAH, NACST can be written as bigrams NAAC, CH and ST. Now by using this we can calculate the bigram based model. By using these bigrams we can easily calculate dice coefficients. We find that only these two bigrams are common in both strings, and cardinality of this is 4 and cardinality of this is also 4. So it will be like 2 into 1 divided by 4. So the bigram based similarity by using Jaccard coefficient will be 1 by 4 between two strings. Now the another similarity measure is Jaccard coefficient. The Jaccard coefficient is used to measure the similarity between sets, and it can be calculated by dividing the size of intersection by the size of union of the sets. It is very simple. Now the other thing is Jaccard distance. Jaccard distance is just 1 minus Jaccard coefficient. Actually, value of Jaccard coefficients ranges from 0 to 1. Jaccard distance measures the dissimilarity between sample sets. It is complementary to Jaccard coefficient and is obtained by subtracting Jaccard coefficient from 1, or equivalently by dividing the difference of the size of union and intersection of the two sets by the size of union. This is simple. Calculating the similarity between query and given documents by using Jaccard coefficients. This is a simple formula. This will clear from this example. For example, this is a given query. It contains 0 T1, means no presence of term T1, 0 T2 and 2 T3, means it contains 2 times T3 and 0 times T1 and 0 times T2. So first in document D3, document D1, we will calculate the score of this query with respect to document D1 and then calculate the score of query with respect to document D2. So it is very simple. Just check the union. Out of 5 T3, only 2 T3 matches with from here, and from document D2 only 1 term T3 present compared to 2 term T3. Now calculating the similarity between query and given document by using Jaccard correlation coefficient. Suppose a given query key Q and document DJ. Then how can we calculate the similarity? For K is equal to 1 to N, total number of documents represented by N. We check the document which contains the query term Q and K is equal to 1 to N, the square of term, again the square of term, minus this portion will give like suppose this is a set A. Suppose this is a set A, this is set B, then this part, sorry, this part will represent only this portion and this portion, not counting this part twice. Means count this part, and count this part once. Same thing is applied here in the form of matching queries and document DJ. Where set of n documents are present. Cosine similarity. Cosine similarity is a measure of similarity between two vectors of an inner product space that measures the cosine of angle between them. For example, the similarity between document D1, which contains term D21, D22 and D2n, and document D1, which contains terms D11, D12 and D1n, with respect to query term Q1, Q2 and to Qn. Calculating cosine similarity. The cosine similarity between query Q and document Dj can be calculated at similarity Q Dj is equal to similarity A and B. A is considered as a query term. It will be equivalent to root under precision into recall. So it is very simple. It will be like mod of A intersection B divided by root under cardinality of A into cardinality of B, and it is also equivalent to Q into Dj, Q dot product Dj divided by cardinality of Q into cardinality of Dj. So cardinality of Q is equal to, from k is equal to 1 to n, W kq whole square and into W kj whole square. Calculating cosine similarity. For example, suppose we have two structures. Now we have to, these are the common bits noted as C. Then what will be the cosine similarity between fingerprinting data A and B? How to calculate? The best thing is use root under precision into recall, and what will be the, and it is equivalent to precision and it will be equal to A intersection B mod divided by root under mod A into and then it will be 6 divided by root under 13 into 8 equal to this. Now another thing is asymmetric similarity. In traditional similarity measures, if A is similar to B, then we find that B is also similar to A. But some coefficients may have been defined in which this is not true. For example, here SA not equal to B, SAB is not equal to SBA. This is called Tversky similarity. Here it is defined as T and can be given as C divided by alpha A minus C plus beta B minus C plus C, where alpha and beta are user defined parameters. Alpha and beta will be equal to 1. Then equation reduces to Denotation coefficient, and if alpha is equal to beta is equal to 1 by 2, then equation reduces to Dice coefficient, and if alpha not equal to beta, then T becomes asymmetric. That is where alpha is equal to 1, beta is equal to 0 and T is equal to C by A. The fraction of A which it has in common with B when T is equal to 1.0 indicates that A is a substructure of B at the level of fingerprinting matching, and when T is equal to 1.0, T tends to 1.0 indicates that A is almost a substructure of B, not complete. Distance based similarity. Till now we studied only matching based similarity. Now we will go through some distance based similarity, basically used in document clustering or clustering based algorithms. The major schemes are or techniques are like Euclidean distance. It stands matrix for geometrical problem. It is ordinary distance between 2 points and can be easily measured with a ruler in 2 or 3 dimensional space. Euclidean distance is widely used in clustering problem, including clustering text. It is also a default distance measure used with k-means algorithm, measuring distance between text documents. Given two documents DA and DB represented by their term vectors TA and TB respectively, then the Euclidean distance between two documents can be calculated as mod of WTA minus mod of WTB whole square and root of entire summation, where WTA is equal to term frequency, inverse document frequency of document term T document A, and term set is represented as T1 to T8, and where M is the TM, sorry, because we used as a TM, because we used as summation as M. Actually, for calculation of such kind of similarity, we represent the document in the form of document vector model, where documents is represented as row and terms are represented as columns. And so on. After that, we calculate the term frequency inverse document frequency of every term. Now, the Euclidean distance will be, suppose this term TA occurs in document, and again the matching terms Suppose this term match, then we can identify the matching of IDF score. But here, to calculate the Euclidean distance between two documents, we just calculate the distance between two similar words in the document. There may be some matching terms or there may not be some matching term. Manhattan's blocks distance. Here distance between query term Q and document DJ can be calculated as from k is equal to 1 to n Wk represents the term and Q represents the query, J represents the document, Q represents the query term, J represents the documents, and K represents the term which is equivalent to query terms, and K represents the term which is exist in the document J. And from k is equal to 1 to n, we calculate the mode of that similarity. Important points: in chess, the distance between squares on the chessboard looks like for rooks is measured as a Manhattan distance, kings and queens by Chebyshev distance, and bishops use Manhattan distance between squares and of squares of same color on the chessboard rotates 45 degrees with its diagonals as a coordinate axis. To reach from one square to another, only kings requires the number of moves equal to the distance of rooks. Queens and bishops requires one or two moves on the empty board, and assuming that move is possible at all in the bishop's case. Thanks.